Good evening, everyone. So now we are going to discuss about a continuation class of amplifiers, that is feedback amplifiers. Okay. Before going to discuss about feedback amplifiers, once I would like to revise last class topics, that is Darlington pair as well as cascade amplifier, cascode amplifier. Okay. So in our last class we have discussed about Darlington pair. So what is the main theme of Darlington pair? So Darlington pair is a circuit which is used to increase the strength of gain. Okay, the gain must be increased with help of our amplifier Darlington. With help of Darlington pair circuits, the gain must be increased. Okay, it must be made with two transistor stages. Okay, like our two-stage RC coupled amplifier, it is made with two transistors, but the two transistors are of common emitter configuration. So in common emitter configuration, the input is applied to the base of the transistor, first transistor, and the output is applied across the emitter of transistor 1, and the output of first stage that appears across the emitter of transistor 1 is connected to the base of transistor T2, and the final output we are getting it at the emitter of T2. The collectors are connected together. So this is the construction of Darlington pair. While coming to the operation, the input voltage is to be amplified is applied across the base of the T1, and the amplified version we are getting at the collector terminal. Okay, and final output is appeared across the base of the next one. So this is the configuration of common emitter configuration, Darlington pair circuit. Here we are going to apply the input voltage, and here we are collecting the output voltage, and both collectors are connected to the supply voltage VCC. Okay, and here what is the main advantage of this is the gain of the whole circuit is very high compared to the usage of individual gains. So here the final gain beta is equal to the product of the individual stages gain. So that is beta is equal to beta 1 into beta 2. So how it is very high. For example, if the individual transistor T1 gain beta 1 is equal to 20 and beta 2 is equal to 30, the final gain would becomes how much? 2 into 3, 6 and 6000. So beta is equal to how much? 20 into 30, that becomes 6, 20 into 30, 600 volts. Okay, so in this way the gain must be increased 10 times compared to the individual stages. For example, if we would like to consider these are individual 2 into 20, 30, it is very less now. By combining both these transistors, we are getting the much more gain compared to the individual gain. So cause of this usage, the rise of Darlington amplifier is very high. Okay, so this is about our last class Darlington pair, and also more two topics are discussed in our last class. One is cascade amplifier and other one is cascode amplifier. First one is what? Cascade. Next one is cascode. The both amplifiers gives the same operation construction, except in cascade common emitter transistors are connected together. Okay, it is a two-stage, it's simply like say two-stage RC coupled amplifier. Here we are connecting output of one common emitter configuration to the input of next common emitter configuration transistor. But in cascode configuration, common emitter is connected to the common base. This is only the different. In cascade, both either NPN or PNP used. But in cascode, one is of NPN type and other is a PNP type, and one common emitter is connected to the common base. Okay, in this way the cascade amplifier consisting of two common emitter configurations and a cascode amplifier consisting of one common emitter and common base. Compared to cascade, cascode gives high input, but in cascade operation is very easy. Okay, and while coming to the advantages of cascade and cascode, so here the simple circuits, no need of using transformers, the circuit becomes simple and inexpensive. Okay, now coming to the next topics. Today's topic is feedback amplifiers and operation. So before going to discuss about feedback amplifier, first of all, what is meant by feedback? Okay, first of all, what is meant by feedback? So see here, the term feedback means, for example, after completion of class, we would like to ask you about feedback. What you are at? Okay, class is somewhat good, understanding and not well. Madam explained too much fast. Like that, the people write something and give to me. So that is called what? Feedback. Means whatever the topic I explained, that is called output. You grasp some output and give it back to me. Okay, fraction of output. You are not explained whole class. Give me feedback about my class means you are unable to explain whole class, but in simple two words. Okay, it is good, understanding, not understanding, too fast, too slow. So whole outputs, from the whole output from 60 minutes class, if you write only one word, then that is called right, and give it to me back, then that is called what? Feedback. Okay, feedback means connecting fraction of outputs back to the input. For example, this is our amplifier circuit. It will produce some voltage here, output voltage. So from this whole output, the sample of output is connected back to the amplifier, then that is called what? Feedback. What is meant by feedback? The fraction of output connected back to the input, then that is called what? Feedback. Fraction of output connected back to the input is called feedback. Is it clear what is meant by feedback? Not whole output. From whole output, if fraction is connected, fraction means sampling. First we divide the output into samples. One sample is connected and connected it back to the input is called what? Feedback. Okay, how can we define the feedback? The fraction of outputs connected back to the input is called feedback. The term feedback is very important. Okay, the fraction of output connected back to the input is called what? Feedback. Okay, and while coming to the types of feedbacks, here feedbacks are of two types. How many types of feedbacks are there? Two types are there. One is positive feedback, other one is negative feedback. One is positive, other one is negative feedback. So here what is meant by positive feedback means, if fraction of output that connected back to the input is called feedback. Now, if this feedback signal, sorry, one second. If this feedback signal, if this is the output, okay, our input is also like this, and this is feedback signal I connected them. So my feedback signal is also like this, means positive, negative, negative. Okay, so here this is my feedback signal and this is my input signal. If feedback signal is in phase with the input signal, in phase na, positive, negative, negative. If feedback signal is in phase with the input signal, then the feedback is called positive feedback. If the feedback signal is in phase with the input signal, then the feedback is called what? Positive feedback signal. Okay, if the feedback signal is out of phase with the input signal, it is not in phase, out of phase. So out of phase means what? See here it is not like this. For example, if it is like this, see, like this. Now it is started with positive now, but it is started with negative. If it is negative, it is positive. Positive, negative, negative, positive. That means if feedback signal is out of phase with the input signal, then the feedback is called negative feedback. Is it clear? So how many types of feedbacks are there here? Two types of feedbacks are there here. What are the two feedbacks? One is called positive feedback, other is called negative feedback. What is meant by positive feedback? In positive feedback, feedback signal is in phase with the phase with the input signal, then the feedback is called positive feedback. So negative feedback, here the feedback signal is out of phase with the input signal, then the feedback is called negative feedback. Is it clear? So two types of feedbacks are there. One is called positive feedback, other is called negative feedback. If the feedback signal is in phase with the input signal, then the feedback is called positive feedback. If the feedback signal is out of phase with the input signal, then the type of feedback is called negative feedback. Is it clear? What is meant by feedback and how many types of feedbacks are there and how can we define? Okay. And see here, here it is a diagram of feedback amplifier is there. See, so here this is the diagram. Already I told you feedback means connecting fraction of outputs back to the input. Okay, so to take that fraction, here one network is used, that is called sampling network. Okay, to collect the samples from the whole outputs, one circuit is used. The name of that circuit is called what? Sampling network. The name itself indicates sampling network. It is a network that is used to collect the samples from the output. And after collecting the samples from the whole outputs, these are connected to the feedback network circuit. It is the circuit, it will connect these samples to the mixture network. So here our mixture network will combines both the input signal and feedback signal to the amplifier circuit. Okay, so this is the block diagram of feedback amplifier. How many number of blocks are there here? 5 blocks are there. What are the 5 blocks? First one is amplifier circuit, next one is sampling network, next one feedback network, mixture network, signal source, that is called input. Total how many number of blocks are there here? 5 blocks are there. What are the 5 blocks? Amplifier circuit, sampling network, feedback network, mixture network, signal source. Is it clear? And see here this V0 indicates outputs and RL indicates load resistor. From load resistor we collect the outputs, and this V0 also indicate the output, fraction of output, and VF means feedback voltage, VO means output voltage, Vs means source voltage, that is input voltage. So here one formula is there. See here, Vs plus or minus Vf is equal to Vd. So what he said, what they write, Vs plus or minus Vf is equal to Vd. So see here we are using plus or minus. So plus or minus indicate what? Whether the feedback signal may be positive or it may be negative. Is it clear? So here Vd is the difference between the Vs or Vf or summation of Vs and Vf. Sometimes it is also write Vs plus or minus Vf is equal to V input voltage. Okay, and see here, if the positive feedback is there here, then that is indicated as Vs plus Vf. If whatever the feedback we connected back to the input is negative, then it is indicated with minus. Is it clear? Whether the feedback signal may be positive or it may be negative, whether it may be Vs plus Vf or it may be Vs minus Vf. Is it clear? So this is the block diagram of our feedback amplifier. So once I would like to explain, see here, the input voltage is must be initially applied to the amplifier having gain A. So now the amplifier will increase the strength of the signal and will produce some output, and this output must be converted into samples, and from the whole output with help of sampling network, some samples are connected back to the mixture network through the feedback network. Okay, and here the mixture network is used to combine the input signal with the feedback signal. Whether the feedback signal may be positive or it may be negative. If it is positive, the final output of mixture network is Vs plus Vf, and if it is negative, output of mixture network is Vs minus Vf, and again it is connected to the amplifier circuit. In this way, in the feedback amplifier, fraction of output is connected back to the inputs. Fraction of output is connected back to the input. Okay, the process of connecting fraction of outputs back to the input is called what? Feedback. If the feedback signal is in phase with the input signal, then the feedback is called positive feedback. If the feedback signal is out of phase with the input voltage, then that is called negative feedback. Is it clear? So this is about what's block diagram of our feedback amplifier. So here mathematical expression is also there. Before going to that one, see they explain the diagram. So see, while coming to the feedback network, so what are the elements inside there in the feedback network? So it is a passive two-port network. Passive means it may be consisting of capacitors or resistors, inductors. Why passive network means only consisting of resistors, capacitor, inductors? Why? Because only these are the passive components. Resistors, capacitors, inductors are called passive components. What is meant by passive? What is the difference between active and passive? Why only these are called passive components? Passive component means they are unable to provide the voltage or currents or source itself. They are unable to provide energy itself. They works with the help of source from the outside. For example, like to active devices, DC batteries, or it may be transistors, all semiconductor devices are active devices. Why? Because they create energy themselves without giving any external input. But resistor, capacitor, inductor, without giving external voltage, they becomes nothing. If we apply some voltage or current or resistor only, then they start functioning. But DC batteries or maybe transistors, because of these are semiconductor devices, by increasing the temperature, some amount, of course it may be fraction of current must be induced. So that active means they provide the energy themselves. Passive means they may not provide the energy. They provide the energy. Active elements, if they don't provide the energy, with help of other devices only they can start their functioning, then these are called passive. Okay, so cause of the network is made with the passive elements, whether it may be resistors or it may be capacitors or it may be inductors or maybe the combination of any two or maybe combination of both three, then the network is called passive network. So here the feedback network is a passive network which will provide the feedback voltage Vf is equal to beta into V naught. Here the beta is called feedback factor or feedback ratio. Okay, Vf is the feedback signal, and beta value is always lies in between 0 and 1. This is very important in your competitive examination. Okay, so in feedback networks, the value of beta lies in between. So options: A 0 to 100, B 100 to 1000, or 0 to 10, last 0 to 1. What is our answer? 0 to 1. Very important. The value of beta is lies in between where to where? 0 to 1 or 1 to 10 or 1 to 100. So many options are there. But whatever may be the options, what is our answer? Only 0 to 1. Okay. So this is about what? Feedback network. And while coming to the next one, see here. Next one is mixture network. We're going to mixture. See here, the beta symbol is used to represent the current gain in common emitter amplifier which is greater than 1. If beta is used in common emitter means Darlington amplifier, their beta value is 20 to 200. But here beta value is lies in between 0 to 1. You remember this. Okay. Here beta value is 0 to 1 only. So next one is what? In our feedback network, mixture network is also there now. Here the mixture network means the feedback signal is combined with the signal from the source. What is the main theme of mixture network or main advantage of mixture network? So mixture network is used to connect or combines the input signal with our feedback signal. already I explained all this. So next one, sampling network. I also explained this. Once see the slide. So here there are two ways to sample the outputs to the sampling parameters, that is either voltage or current. Voltage sampling means depends upon the parameters. The sampling are of two. One is voltage sampling, second one is current sampling. If the output voltage is sampled by connecting the feedback network that is sent across the outputs, or current means voltage is connected in parallel, current is connected in series. Depends upon the parameters, the sampling of two types. The voltage is connected in parallel, the current is connected in series. Is it clear? So, and see here, here it is the expression. Next is our mathematical expression. Okay. Before going to this, once I would like to revise see the diagram. Why? Because it is very important topic. See, so in block diagram of feedback amplifier, 5 blocks are there. So feedback network is made with passive elements are the resistors, capacitors, inductors, and here the feedback network is used to connecting fraction of outputs back to the mixture network. Okay, and the feedback network provide the voltage Vf that is equal to beta into V naught. Here the beta values are lies in between 0 to 1. And in our block diagram, next new one is sampling network. So here the sampling network will provide the samples in two forms according to the signals. The output is in the form of voltage or it may be in the form of current. If the output is in the form of voltage, it connects the voltage samples to the feedback network in parallel only. If the output is current, it will connect the current to the feedback network in series form only. Means what? Voltage is connected in parallel way, current is connected in series. And next one is mixture network. Here according to the feedback signal, the mixture network either may add or it may subtract. If feedback voltage is positive, then it will add the feedback voltage to the input signal, and if it is negative, it will subtract the feedback voltage from the source. Okay, how many types of feedbacks are there? Two types, positive, negative. When positive occur, what is meant by positive feedback? If feedback voltage is in phase with the input voltage, then that is called positive feedback. If it is in out of phase, then that is called negative. Somebody getting? If it is positive only called positive feedback now? No, if it is in phase, if the input signal is positive, it is also called positive feedback. Sometimes it also may like this. Means the input is started with negative going signal, feedback is also going negative going signal started with, then this form is also called positive feedback. Somebody getting dot. It is negative na. Negative or positive, but both are in phase na. Negative, positive. If both are in phase, whether it may be positive going signals or it may be negative going started signals, if both are in phase, then that is called what? Positive feedback signal. If feedback signal is in out of phase with the incoming signal, then that is called negative feedback. So now I would like to see the expression of mathematical expression of gain for the feedback amplifier. So see here, for example, our circuit is like this. Where is our circuit? See the circuit. So it is our circuit here. Gain A is equal to what? Here gain A is equal to output voltage V naught by V in. Okay, output by input is called gain, but A is equal to V naught by V input voltage. Okay, so output voltage V naught is equal to what? A into V in. So here this fraction of output voltage is connected back to the input voltage, and here Vi is equal to what? Vs plus beta into V naught. Why? Because Vi is equal to Vs plus or minus Vf. So Vi is equal to Vs plus or minus Vf means Vs plus or minus B into V naught. Okay, once see here. So output voltage A is equal to what? Here again A is equal to this output voltage by input voltage, that means V naught by V input voltage. But here it is rewritten as output voltage V naught is equal to A into Vi. But according to here, this Vi is equal to what? Source voltage Vs plus feedback voltage plus or minus Vf. But here it is written as Vs plus or minus Vf is equal to, already I told you, beta into V naught. So finally here this output voltage V naught is equal to what? Vs plus or minus beta into V naught. Here these two terms are same, you take it this side, V naught plus or minus V naught is equal to Vs. So here V naught is common. Okay, V naught is common, and it is written as 1 plus beta is equal to Vs. So what we are getting here? So output V naught by Vs is equal to 1 by 1 plus beta. So cause of feedback. So what is the feedback? Voltage gain with feedback AVF is equal to V naught by Vs, that is equal to 1 by 1 plus beta. The gain must be reduced. The gain must be reduced cause of feedback. See here, whatever the explanation I derived, finally we are getting it only 1 by 1 plus beta. See here, V naught is equal to A into V1 plus B V naught, and V naught into 1 minus BV is equal to AVN. Okay, and finally the voltage gain is equal to AF by V I by V naught, A by 1 minus A beta. So here our gain is divided by 1 minus A beta, or 1 minus plus or minus A beta. It must be reduced. Okay, and see here, in the positive feedback increases the amplifier gain, but the negative feedback, the feedback fraction is minus beta. Okay, see here, while coming to the next one, differences between the positive feedback and negative feedback. So already I told you the main difference is between the positive feedback and negative feedback. The positive feedback is in phase with the input signal. In phase means positive, positive, negative, negative means 0 or 360 degrees. But in negative, it is in out of phase with the feedback signal. Okay. Okay. So out of phase means 180 degrees. In negative feedback, the feedback signal is out of phase with the input signal. In positive feedback, feedback signal is in phase with the input signal. So that's why in positive feedback it provides 0 or 360 degrees. In negative feedback it provides 180 degrees. Okay, so that overall phase shift around the circuit in positive feedback is 0 or 360. In negative it is 180 degrees. Okay, and while coming to the next one, input and output voltage and noise. So input voltage is increased due to the feedback. In positive feedback, output voltage also increased, at the same time noise also increased. So in positive feedback, all parameters are increased. Input voltage is increased, output voltage is increased, and noise is increased. But in negative feedback, input voltage is decreased, output voltage is decreased, and also noise will be decreased. And see here, while coming to the next point, feedback signal and input signal. Already I told you, both are in phase. Cause of in phase only it will provide 0 or 360 degrees phase shift in the circuit. And in negative side, both are out of phase. how much out of phase? 180 degrees. If it is positive, next one is negative. If feedback is negative, input is positive. Okay, and while coming to the next point, stability. In positive feedback, compared to the negative, it becomes poor, but compared to the positive, negative becomes somewhat better. Okay, and while coming to the applications, oscillators are the applications of positive feedback. Why? Because it produces 360 degrees or 0 degrees phase shifting. This 0 degrees or 360 degrees phase shift is used to provide the oscillations. Why? Because if any circuit having 360 degrees phase shift, only that is able to produce the oscillations. Why? Because oscillation means it having both positive half cycle as well as negative half cycle. So positive 180, negative 180 means total it becomes 360. If any circuit having the ability to produce 360 degrees phase shift, then it acts like an oscillator. Okay, that's why the applications of positive feedback are main and important application of positive feedback are oscillators. All oscillator having the feedback of 0 or 360, and the negative feedback, that is 180 degrees only produced, and that is used in amplifiers. These are the main differences between positive feedback and negative feedback. Okay, what is our first point? Overall phase shift around the positive feedback is 0 or 360, and in negative feedback it is 180 degrees, and input voltage, output voltage, noise parameters are increased due to the positive feedback, and these are decreased in negative feedback circuit. And the feedback signal, input signal, both are in phase in the positive feedback, and both are in out of phase in the negative feedback. And while coming to the stability, positive feedback circuits becomes poor, and negative feedback, the stability becomes somewhat better, not complete compared to the positive. Okay, and the positive feedbacks are used in oscillators to provide the oscillations. The circuit must and should produce 0 to 0 or 360 degrees, and in negative feedback circuits is used in the amplifiers. Okay, this is about the difference between the positive and negative feedbacks. And see, while coming to the next important topic, voltage series feedback means types of feedbacks. Already I told you two types. One is positive feedback, other is negative feedback. While coming to the other types, depends upon the parameters. The feedback amplifiers are classified into four types. First one is voltage series feedback amplifier. That means here whatever the factor we are connecting, that is voltage, and it is connected in series with the input voltage. The feedback voltage is series in with the input voltage, that is called voltage series feedback amplifier. Next one is voltage shunt voltage shunt feedback amplifier, and the next one is current series feedback amplifier, and the last one is current shunt feedback amplifier. Okay, how many types of feedback amplifiers are there based on the parameter and their connection? Four types are there. So based on the parameter, voltage amplifiers and current amplifiers. Based on the connection, voltage series feedback amplifier, voltage shunt feedback amplifier, current series feedback amplifier, and current shunt feedback amplifier. Is it clear? See here, this is the diagram of voltage series. So here we connecting the sample of voltage from the output. Okay, this is the feedback network we are getting here. So here see, this is voltage series current amplifier. So in voltage series feedback amplifier, whatever the parameter that is connected is for the voltage, and it is connected in series with the feedback voltage. So see here, this is the gain that is equal to output voltage by inputs, and this is the output voltage. So from here we are taking sample and it is multiplied with the factor beta. So Vf is equal to beta into V naught, and this voltage is connected in series with the input voltage. How it is connected? In series with the input voltage. So this is about voltage series feedback amplifier. In our examination only, or in our syllabus only, diagrams are there. Okay, see the diagrams. Next one is voltage shunt feedback amplifier. Only small difference is there, see. So in voltage series, here the connection is simply replaced with, this is directly connected here, not here. So series means it is connected to here and disconnected here, and this connection is opening. Okay, this terminal is connected to this one, and this terminal is directly connected to here. So that connection is called a series. But in parallel connection, the starting is connected to starting and second terminal is connected to second terminal. So this is only the difference between voltage series and voltage shunt feedback amplifier. In voltage series, input is connected to the one and this one is connected to here. But in voltage shunt feedback, input terminal is connected, means if two terminals are there, first one is connected to first one, second one is connected to second one. That is only the different, and in this way we made the connections. Here the input voltage is connected in parallel with the feedback voltage. Okay, and while coming to the next one, current series feedback amplifier. See, and this is the diagram of current series feedback amplifier. So here the whatever the parameter we would like to collect, that is current, it is indicated with I naught. Okay, it is current I naught that is indicated with I naught. The amplifier gives voltages if the voltage, okay, the current must be passed through the resistor, we are getting voltage. If it is directly connected by lowering the resistance to the feedback network, then that is called current network. And series means, already I told you, if the second terminal is connected to the source voltage, first terminal is connected to the amplifier. If two are directly connected to the basic amplifier, then that gives shunt connection. But one terminal is connected to the source voltage and the second terminal is connected to the amplifier, then it gives a series connection. In previous one, parameter is voltage, here the current is parameter, no need to by add. If it is current shunt, simply you add both these. This one is connected to amplifier and this one is also connected to amplifier. Okay, once check that one also. See, this is the block diagram of current shunt feedback amplifier. Whatever the changes I explained, those are there here. Here it is connected to the, means one terminal is connected to the first terminal of amplifier and second one is also directly connected to the basic amplifier, and here the source is directly connected. So see here, these are the four different types of feedback amplifiers. So according to the signal connected, the amplifiers are classified into two types feedback amplifiers. One is positive feedback, other one is negative feedback. But according to the parameters usage, there are two types, voltage feedback amplifier is there and current feedback amplifier is there. But according to the signal is to be connected to the input, means according to the input signal is connected to the feedback signal, voltage are again classified into two types, voltage series feedback amplifier, voltage shunt feedback amplifier. And next, while coming to the current series feedback amplifier is there and current shunt feedback amplifier is there. Okay, so according to the signal is used, amplifiers are of two types, positive feedback, negative feedback. And according to the signal used, voltage are there, current is there. So here, according to the connection, these are classified into two types, voltage series and voltage shunt. And according to the connection, current is again classified into two types, current series and current shunt. Okay, in this way the amplifiers, feedback amplifiers are classified. So while coming to the gain of positive feedback, here AVF is equal to A by 1 plus or minus A beta. Okay, AVF is equal to A by 1 plus or minus A beta. It is plus for positive feedback and minus for negative feedback. In positive feedback amplifiers, the gain must be reduced. At the same time, also ripples must be eliminated. Circuit becomes stable. Okay. Now tell me, while coming to the frequently asked questions, very important question is derive the expression for gain of feedback amplifier. So what is the important question or 5 marks question here? Derive the expression, mathematical expression for the feedback amplifier. Gain, derive the mathematical expression of gain for the feedback amplifier. How can you derive? First you write gain A is equal to what for the amplifier? Output voltage by input voltage. From this equation, here output voltage is equal to what? A into input voltage. But input voltage is equal to what? It is the mixture of source voltage plus or minus feedback voltage. But what is meant by feedback voltage here? A Vs plus or minus beta into V0. Why? Because feedback is equal to beta into V0. And after multiplication, we are getting A into Vs plus or minus A into V into V0. And while retrieving the term here, V plus or minus A B V0 is equal to A into Vs. And V0 is common. Take here 1 plus A B is equal to A into Vs. And while rewriting the equations, we are getting output voltage by input voltage is equal to 1 by 1 plus or minus A into beta. Okay, so this is the mathematical expression of feedback, means gain with feedback. Gain with feedback is equal to 1 by 1 plus A beta for positive feedback and 1 by 1 minus A beta for negative feedback. This is very important question and it is a 5 marks question. Derive the expression for gain of feedback amplifier. And sometimes it is also asked like explain the working of block diagram of feedback amplifier. How many number of blocks are there? Total 5 blocks are there. Sampling network is there, mixing network is there, feedback network is there, and amplifier circuit is also there. So how the feedback network is made? What are the elements used in the feedback? Passive components, whether it may be resistor, capacitor, inductor. And how what is the function of sampling network? It provides the samples of output voltage, whether it may be the voltage or it may be the current. What is the use of mixing network? It will mix the feedback signal with the input signal. And what is the feedback voltage? Vf is equal to beta into V0. Here beta is equal to what? Beta is the feedback factor. What is the value of beta here? 0 to 1. Okay. So this is about what? Feedback amplifier and the expression of feedback amplifier. In your competitive examination, the questions are like this. The gain of feedback voltage AVF is equal to what? AVF is equal to what? A by 1 plus or minus A beta. A by, this is one option. Second option, A by 1 plus or minus beta. A by 1 plus or minus A, none of the above. What is our answer? A by 1 plus or minus A beta is our answer. Okay. So these are the questions came in our competitive exam. And already I told you one more important question. The beta value in feedback amplifier lies in between A 0 to 1, B 0 to 100, or C 0 to 10, none of the above. What is our answer? 0 to 1. These are the multiple choice questions. And next question. The phase shift produced in the positive feedback circuit, phase shift, okay, A 360 degrees or 0 degrees, or sometimes they ask like this. First one, in positive feedback networks, the phase shift around the circuit is 360 degrees, B 0 degrees, C 180 degrees, D A and B. So what is our answer? A and B. Okay. And the next one, negative feedback network. The phase shift around the circuit is A 180 degrees, B 360 degrees, C 0 degrees, D none of the above. What is our answer? 180 degrees phase shift is provided in the negative feedback. And where we are using positive feedback circuits, oscillators or amplifiers, all of the above, none of the above, only oscillators. And where we are using negative feedback, amplifiers or oscillators, all of the above, none of the above, where we are using amplifiers. Okay, so this is our today's class. Now I would like to do the conclusion and meet you in next session.